So I will just make a very quick introduction before the session. I want to introduce you to our core organizing team. So Gustavo is over there. Gustavo, say hi. Veshali is there. Andre is joining online, so I'm Svetlana. And we are supported second year in a row. Bloomberg Engineering is sponsoring us, so we were able to provide student grants this year. So SCAI refers to search-oriented conversational AI. It was started in 2017, was first collocated with ECIR, then it traveled to the major NLP and AI conferences. So last year we held it online, and it was an independent event. So you can find our recordings online. We're gonna put this here as well on the same YouTube channel. So we changed the format a little bit. We have 4 sessions. Each session has 4 short presentations, followed by the panel discussion. So each of the presenters on the panel, and we very much want you to get engaged. So asking questions, we can also answer, comment on the questions. So feel free to use this URL. It's for submitting your questions, for upvoting someone's questions, so then Mark can make use of this interface to moderate the discussion. So bit.ly/SCAI QA. So we are also on Twitter. We're going to be live tweeting this session. So this is the menu for today. We start from the end, from the evaluation, to understand the dimension of conversational search and how can we measure progress with some evaluation metric. So the next session is going to deep dive on several applications, namely product search and cooking recipes. So we're going to look more in detail at the kind of interaction that happens in these domains to sort of draw more general implications for architecture of conversational search system that can support such kind of interactions. The last 2 sessions, they are more technical ones. So they're going to introduce the state-of-the-art on question answering and mixed initiative clarifying questions. And what we want to discuss there is how to go beyond simple sequences of question-answer pairs towards the kind of dialogue interactions that we were discussing at the previous 2 sessions. All right. At time, I hand over to Mark.
Okay, thank you very much. So the first session is on evaluation. And so what we're going to do is we've got 4 speakers. Svetlana will tell me if I'm doing something wrong. But we're going to go through those first 4 speakers, about sort of 7 to 10 minutes for each presentation, and then we'll have a conversation around these around this topic of evaluation. So our first speaker is Jing from the University of Melbourne, which I believe he's online.
She's online, sorry. Okay. Hello, can you all see my slides?
Not yet.
Not yet.
Yeah, we can see them now,
Okay.
Thank you.
Oh, my camera. All right, I hope you can see my face as well. So I'll just start presenting. So first of all, greeting from Asia. Today I'll be talking about a paper. A nice way to put up this work is that we conduct an empirical study in the wild about how people use smart speakers. A better way to put it is that I have some leftover data and I figure I probably should publish a paper based on the leftover data. So here it is. The paper's title is called "What Could Possibly Go Wrong When Interacting with Proactive Smart Speakers?" A case study using an ESM application. So to start, this is a proactive smart speaker. You can see I have a Google Home and a Raspberry Pi. So in essence, the Raspberry Pi will activate the Google Home by secretly speaking invocation command to have the speaker to have this interaction. So basically, it will other than conversational search or typical Q&A systems, I have a speaker to ask users questions. So here's the conversation flow. So as you can see, this is a very simple conversation. And for users, the user only needs to speak like 1, 2, 3, 4, 5, and a very simple free-form phrases such as presenting. But the thing is, you might think, how hard could it be? It's just numbers and free-form answers. And it should be quite easy and straightforward because it's very simple. What could be the interaction errors? So what I find is that in total, we've recorded about 1,200 experience sampling interactions. Among those 1,200 experience sampling surveys, about 85% are completed and 40% are incompleted. Before we dive into those incompleted ESMs, I would like to see the completed one. As you can see that for 0 errors, remember our dialogue consists of only maybe like 9 turns. So among those 9 turns, we about, I think it's 60% of experience sampling have no errors, but the rest, about 40% have at least encountered 1 error or even 2 errors. And what's worse is that the time cost brought by those errors are quite high. So on average, to answer 1 question, for example, what is your boredom level? Then they usually say 1. On average, it takes about 10 seconds to complete such interaction. But the thing is that once 1 error happens, either the speaker that did not catch what the user was talking about, or the speaker saw the user did not answer a number rather than answer like banana, then it will prompt an error. So such error will add more than 10 seconds into the total interaction time. The worst thing is that with 2 errors, the interaction time would be more than tripled. So, and what if sometimes 3 error happens? When 3 error happens, the whole interaction is terminated because the speaker mechanism is like that. If you trigger 3 errors, the system just think, okay, we need to end the conversation. But when I was looking at my data, I thought there are like 15% of incomplete interaction, and I didn't know why that. I thought it's because the proactive speaker initiating at some random time, the user might be far away from the speaker and they may attempt to answer the questions delivered by speakers remote, like at a far distance. So they might think, so they may like make some mistakes, or they may like just want to mess with my data. So they say something rather than numbers, and which eventually triggered 3 errors to happen and eventually terminate the whole conversation. But the thing is, it's actually, that's what we call it a cumulative termination. So because of 3 error happens, the interaction is terminated. But what actually happens is what we call sudden termination. So here's an interesting example of the sudden termination. So basically, in this example, I show that the speaker misinterpreted the number 5 as buy, and then once the buy was given to the speaker will say, "Oh, see you later, alligator," and the conversation just ended. And the buy is kind of phonetically similar to 5. That's why this error triggered. But by default, by my program, Google should actually correctly transcribe 5 as buy, and the buy should not be an ending phrase. But in my application, this has happened, and this is actually causing about like, I would say about 80% of the ESM that's being incomplete. And here is a kind of small breakdown of accumulated termination versus sudden termination. As I said, we presume that most incomplete ESMs were caused by accumulative termination, but that's not. And there are some examples about why sudden termination happens, which took me some time to figure it out. We can see that sometimes the user would give an answer 2, and 2 can be wrongly transcribed as poor, tattoo, and chew. And once these words are triggered, they actually somehow trigger the Google speaker's map searching function. Once the person say 2 and the speaker heard, oh, pool. So then to respond, the nearby swimming pool is 2 kilometers away from you. At first, I was very confused, just as my participant was. But like by gradually listening to the audio recording from my study, I just realized this is actually quite common. And also 3 can be recognized as train and hey, and 5 can be recognized as buy and play. All this either triggered different, like an incorrect application by talking to a speaker, or suddenly terminating the interaction. And the worst thing is that I thought I collected 1,200 ESNs, but when I listened to all the audio recording, I realized that there are like 30 more interactions that were terminated before any responses were recorded, because such termination happened before the first answer was recorded, which I would say if a future researcher wants to use my system to collect data, this is somehow a risk of missing data for the study. And also for hey and play, it is also a very interesting finding in my study. So hey and play sometimes will reinitiate my application. At first, I was very confused, but then I started to think, so in order to have speaker to activate my application, it has an invocation command, but somehow Google consider hey or play to be the initiating invocation command. So then it starts the whole interaction, and which results in some double entries for one participant at one time point, which also caused a lot of trouble in my data analysis. But these kind of errors were unexpected, and I won't say I was happy with it, but I was very happy to find this out, because this actually empirically tell me and probably tell others there are some unknown errors that can happen in the wild, which people may be missing. Especially many people try to understand the interaction with smart speakers by looking at the conversation logs or by looking at the data recorded on the database. But in reality, there are many nuances and many things that we miss if we don't actually look into the real-time interaction. So also, I've noticed a few user strategies that people adopt to try to overcome the errors. So like, for example, repetition, we all know it's a very common strategy, but the repetition can actually cause further delay. One significant thing that I find with the interaction with smart speakers is that because smart speaker is a cloud-based system. So for example, I did this study in Australia, but when I started my PhD, I accidentally deployed the server in central US. I'm pretty sure that there's a geography difference which cause there further delays from sending data from by sending data from Australia to US. Then here it is. Sometimes the delay can be a few seconds. Think about it. When we call another person, we have a gap of 1 second. We are suspicious. We may think the other person is not listening. But the gap with smart speakers is like 6 seconds. That's really, really long. And people, when they see this uncertainty, they try to repeat, and which causes further delays because the speaker keeps receiving the new information, then transmit that to cloud, then sending that back. And it can also lead to double response errors. And there are also phonetic and lexical changes. Phonetic changes are fine, just how people tune their pronunciations, but they also kind of lexical changes. They are like about 10% of data people have the changing numerical answers. For example, 1, 2, 3, 4, 5. I have one participant who literally uttered all 5 numbers because he could not get any response from the speaker. So this would be undiscovered if I didn't spend my time listening to the audio recorded during the study. And they also help from others collaboration. This is actually quite common strategy, and I also find this in my data set. So here are the implications for my study. The first is use better words. In my study, I tested like 1, 2, 3, 4, 5. Among those words, 2, 3, 4 are kind of bad in some way, because if you only have a single word, the single word recognition accuracy is only about 70%. So maybe there are other words that's better. And we really need to think about if we want to deploy smart speakers or these voice interface systems in the wild, we really think about the ASR errors and the discrepancies. So the discrepancy are mainly from what the user really said. For example, I could say, I want a banana, but the speaker may interpret that as something different. And so that based on that, we also need to know what the speakers really heard. So there are discrepancy between these two, which can probably help us to understand why certain user behaviors happen and why certain errors occur. And there are also hidden dialogue logic flaws. As you can see, my dialogue is pretty simple, but I never realized that the play and hey can actually be a alternative to my very long invocation command in my application. And I guess that's all my presentation. I hope I'm actually efficient. And if you want to find me, you can scan the QR code.
Okay, do we have any questions for the speaker? Oh, yep.
Hi, thank you for your talk. This might seem like a very naive question, but it's really confused about this. Why can't you simply constrain the ISR output to be 1, 2, 3, 4, 5?
Oh, actually, because for Google Speaker, so all the application you deploy, the transcription, the ASR is done by Google Assistant. So there's no way for us to actually kind of custom it or fine tuning it.
Okay, thanks.
Yeah, there was a similar question on the Slido thing as well. It's just sort of saying, has that question just disappeared? Yeah, any other questions? Yep.
So if you face the ASR error, then have you tried any ASR error correction after the ASR was given by the Google?
No, as I stated in the beginning, this is just some leftover data that I figure might generate a publication. So we didn't actually do anything.
Okay, I think we can probably leave things there for the time being. So, Jing, thank you very much.
Thank you.
Yeah, thank you. So next up we have Guglielmo Faggioli, who I'm sure I've just destroyed their name, from the University of Padova. I think, again, this speaker is online. I apologize for destroying their name, by the way.
Oh, don't worry. Okay, so let me share the presentation. Okay. Sorry, I was planning to join you in Madrid, but COVID blocked me at home, so we will have to deal with what we have. So the work that I'm going to describe is a joint effort with Marco Ferrante, Nicola Ferro, Raffaele Perego, and Nicola Tonellotto, and mostly revolves around the way in which we evaluate conversational systems and mostly conversational search systems. So among the whole family of conversational systems that we all work with, our focus was on multi-turn conversational search. So we have to imagine a system that interacts with the user. In particular, the user asks factual questions to the system, and the system search the answer for that utterance over a corpus, taking, for example, a paragraph or a document in response to the system. And this happens for multiple turns. So we have to somehow remember the context of the conversation. So our opinion was that the way in which we evaluate these systems, so using pre-made conversations doesn't really represent the reality. In fact, different users might generate a different series of interactions with the systems, and in this sense, the documents provided by the systems themselves might change the way in which the user interacts with them. So our opinion was that probably we need a way to simulate new conversations starting from the ones that we have, in order to increase the amount of information that we are able to extract from our collections. In particular, we want to generate these new conversation automatically. So starting from conversations that are already available, in particular CAST 2019, we use that collection, and such new conversations need to respect some constraint. In particular, they need to maintain temporal dependencies among utterances and also the meaning. So we classified utterances into 4 main categories. We have a first utterance, which roughly gives the context of the conversation. We have some self-explanatory utterances that can be answered by the system regardless of their position and in general of their context. Any system should be able to answer to self-explanatory utterances, not only conversational one. Then we have previous topic utterances, which are related to the self-explanatory utterances that precedes them immediately. And finally, we have some first topic utterances, which are related to the general context of the conversation, but they do not really require to link them to a specific utterance in the conversation. But it's enough to just know the general topic of the conversation in order to answer them. So our permutation strategy was based on the following step. First of all, the first utterance needs to remain in its position. It gives the general sense of the conversation, so we cannot move it from where it is. Then self-explanatory utterances can be moved freely on the conversation sequence, since they can be answered regardless the information to their position, while previous topic utterances, which are linked to self-explanatory one, need to remain very close to them, but can be switched among clusters of previous topic utterances related to the very same self-explanatory utterance, which was immediately previously. Finally, we have first topic utterances, which again are pretty general and only depend on the general context of the conversation, so they can be moved anywhere into the conversation and still maintain their meaning. What we observed is that if we use our permutation and we evaluate systems over our permutation, the default conversation, the one used in CAST, is often not the best one. So we can generate permutation which induce higher performance on the systems that we considered. We consider 9 archetypal systems, very simple, mostly as representatives of different families of systems: lexical, pseudo-relevance, feedback-based, something very simple based on a large language model. And what we've said is, in fact, that permutations are able to achieve higher performance compared to original utterances, conversations. So this gives us the idea that somehow the original conversations might be biased, or in general might favor some systems over the others. Also, if we consider pairs of systems and we watch what happens when we compare given a set of permutations to systems, as in this case, the last topic system, which is roughly based on concatenating utterances, and RM3 previous, which again is based on pseudo-relevance feedback in order to provide the needed context to answer the utterance. What we observe is that for 22 different permutations, the second system is the best, while for 26, the best one is the other. So this gives us the idea that depending on which conversation we take, one might be better than the other. So if we consider only a single permutation or only the default way of expressing that conversation, then we are somehow favoring one system over the other, while in reality they are much more similar than what we expected. So we also tried using permutations in really evaluation settings. So we applied them and we used ANOVA. And what we observed is, in fact, that permutations are able to increase the power of our tests, allowing us to better discriminate between systems. So they, in fact, help better understanding which system is the best and which system is able to handle multiple different ways in which the conversation might actually go. We also have a way to permute such utterances in order to maintain dependencies. Obviously, there are some flaws and some drawbacks. For example, it is really hard to handle multiple references or utterances that refer to multiple previous utterances. But in general, the conversation are somehow realistic and working. In fact, some systems tend to perform even better than what happened with original conversations, which again might be biased, favoring some systems over the others. So in a sort of way, making it hard to distinguish between them. So in general, the work still has some steps to do, among which we certainly plan to investigate how good is the quality of the permutation via a user study, asking the users what do they think of the generated permutations. So this is it from my side. Thank you very much for listening.
Do we have any questions for our speaker? Yeah, please.
Thank you for the talk. It was very nice. One question I have, so this taxonomy of utterances you showed, is that specific to TrackCast, or do you think this holds for more general conversations as well?
Well, to be honest, I think that this is pretty much the way in which we interact with the systems. Obviously, to have such a deep taxonomy requires somehow long conversations, which might not be the usual use case with typical as a conversational assistants. So it is needed such big taxonomy because we have long conversations, but what typically happens is that we start with a question which roughly gives the idea of the context. So often without that question, it is impossible to understand the rest of the conversation. Then there are these self-explanatory utterances, and in that case, it is clear that somehow we ask new questions. We might put there some topic drift, and in this sense, there are always some utterances that can be really understood in any case. While the subsequent one, especially the previous topic, is pretty much the odd element of the conversational task in general. So utterances which contains anaphoras or other rhetorical figures which might be hard to be interpreted, and probably that is the reason why we need conversational systems. And finally, first topic, utterances in reality is more of a big container for all these utterances that do not agree with any of the previous classes. So in this sense, probably we might even think to deeper taxonomies with, I don't know, for example, clarifying questions or other kind of interactions. So yeah, in my opinion, I'm not sure whether all the conversations need all these different classes, but in general, this might be a realistic scenario. Yeah.
Any other questions from the audience?
Hi, thanks for the talk. So I was wondering if you tried automatically predicting these kind of topical shifts, and whether this type of data is necessary for predicting topical shifts and kind of same threads of the conversation. And yeah, is this, how much data do we actually need for doing that for conversation search systems?
To be honest, we haven't tried. This classification is based on a work from Mele et al. From 2019, if I recall correctly. So we used their annotated data, and in this sense, we didn't do it automatically. But if I recall correctly, in the original paper, they tried to use this classification in order to annotate automatically the utterances with the objective of improving an actual conversational system, so to actually develop system rather than evaluating them. So yeah, in this sense, it has been done, although not by us. And if I recall correctly, they used only the cast data, so the amount of data which is typical of track, few tens to hundreds of different conversations, not a huge amount of data.
We also have a question online where, let me get close to the screen. Gustavo asks, how generalizable do you think the types of utterances you defined are when you consider datasets other than TREC-cast? We would still observe a good amount of utterances that can be permutated without affecting, would we still observe a good amount of utterances that can be permutated without affecting the dialogue?
Well, to be honest, again, I think that there are some classes which are obviously of utterances which obviously cannot be permutated. For example, if I ask to the user to clarify, actually to the system to clarify their answer, then obviously it is not so obvious to permutate it in any way, since it is directly linked to the previous one. Yeah, in general, this classification should be thought for conversational systems, conversational search systems, with the specific aim of producing an answer in a typical information retrieval scenario where we have a set of documents which provide us the answer. So in this sense, the evaluation itself is not meant for a fully general conversational scenario, in which again we are really not interested into, since again the main point here is to somehow take into account the context that flows through the different conversations. So we are imagining long conversations with the user asking continuously for specific information needs in a very factual way, let's say. Other scenarios, such as the construction of the question or in general different types of conversations, might require different permutation strategy. My point is that even though the very type of utterances that we defined here might not work for different scenarios, the important thing is that still different users might generate different type of conversations. So in this sense, rather than understanding whether we are able to apply this very same classification in other scenarios, we should somehow find a way to add more information and be able to grasp all the possible type of interaction that a user can have with a system, even in different scenarios. So yeah, maybe this is not exactly the classification that fits all the scenarios, but we should imagine also classifications that work in that case.
Okay, thank you very much. I think we'll probably move on to the next talks. Okay, so thanks very much. Thank you, everybody. So I believe the next speaker is here. Yeah, so Young Kim from University College London. and this is a multitask-based neural model to simulate users in goal-oriented dialogue systems. So yeah, go for it. See if it works for you. Yep.
Yep. Hello, I'm Toon Kim. I'll be presenting the work multitask-based neural model to stimulate users in goal-oriented dialogue system. This is a joint work with Aldo Lipani and accepted as a short paper in SIGIR 2022. So the motivation of the research comes from the challenges in goal-oriented dialogue system research, and those are partly solvable by the user simulation. So the first challenges we face is the data scarcity issue. So by the user simulation, we can generate a vast amount of synthetic data, synthetic dialogue histories. And the next is the evaluation. So the current evaluation metrics can evaluate either the single path or the single turn of the dialogue history. So by using the user simulation, we can let the dialogue system chat with the user simulator, and we can evaluate the metric within the dialogue, within the user simulation, such as the satisfaction scores. Lastly, the training and refinement. So for example, when training a dialogue manager, we can give the user simulation as an environment when training with reinforcement learning. So the two papers have influenced our work heavily. So the paper on the left side, you can see is the work that was published last year at SIGIR as a research paper. It was by the Sun et al. They showed the system responses are correlated to the user satisfaction score. In their paper, they show the importance of the user satisfaction tracking in the user simulation research. And they released the user satisfaction simulation data set, which is called the USS, for further user satisfaction modeling research. And they experimented with that data set and published some of the base models for the user satisfaction prediction and action prediction. The paper on the right side, by the Ben David et al., they used the multitask learning for improving user intent prediction, and they used the utterance generation as one of the auxiliary tasks in the multitask learning. So the data set we are using is the USS data set that I said earlier. So it contains the turn level annotations of user satisfaction scores in the 5-point scale, so 1 to 5 integers, and also the actions, as you can see on the right side of the slides. It's the example of the SGD data set. So it comprises of the 5 conversational data sets, including the multi-WAS 2.1, SGD, and then CCPE. So we make 2 hypotheses. And before we make the hypothesis, let me introduce the 3 models. So the model in the middle, which is called the SAT-ACT-ODD, is the main model that we propose. So we give satisfaction score prediction, action prediction, and next utterance generation as a 3 task in a multitask learning settings. And we are going to predict those 3. And the model on the left side is called SAT-ACT, and we only give the 2 tasks, which are satisfaction score prediction and action prediction. And model on the right side is just the utterance generation. So the hypothesis 1 is that if we see the improved performance of the satisfaction score and action prediction in the SAT-ACT-ODD model compared to the SAT-ACT, it means that adding the utterance generation task to the SAT-ACT-ODD model can help boost the performance of the satisfaction score prediction and action prediction. Hypothesis 2 is that if we add the satisfaction score and action prediction task to the utterance generation model, which is the UT model, it means that the satisfaction score prediction and action score prediction task can help boost the performance of the utterance generation. For the data preparation, we transform the data set into the format that you can see on the left corner, top right corner. So the HI is the dialogue history. We also give the model the satisfaction score and action and the utterance. We provide up to 10 dialogue histories, and the model should be able to predict the next satisfaction or next action or next utterance, so 11th of them. And we also tackle the data imbalance in the USS data set. So if you look at the data set, there are many 3-rated ratings. So most of them are like 3 through 3, and some of them are 1, 2, or 4 and 5. So to tackle the imbalance of the data, we calculate the ratio between the non-3 and the 3 ratings, and we set specific upsampling factor for each data set. So if you look at the table, it's 7.5, 5.0, and 3.3, 3.5 for each data set. And while upsampling, we use randomized text augmentation data while upsampling the data set. So as an experiment, here are the experiment details on the bottom. We use a T5 model, which are very suitable for the multitask learning because they use a fully text-to-text manner, and we can use the loss function, which is a negative log likelihood. And when evaluating those 3 tasks, for the satisfaction score prediction, we use unrated, average recall, Cohen's kappa, Spearman's rho, and F1 score. And for the action prediction, we use accuracy, precision, recall, and F1 score. And for the utterance generation, for the automatic evaluation, we use blue, rouge, and semantic textual similarity. And for the semantic textual similarity, we use the cosine similarity between the embeddings that we've taken from the robota. So here are the results. The first results, the table 2, is a user satisfaction prediction, and the bottom one is action prediction. What you have to see here is that the first 2 models, the high GRU and the BERT models, were the baseline models that were given by the previous paper, and then the last 2 ones are the proposed model that we propose. The first point that you have to see that is the SAT-ACT and the SAT-ACT-UT generally performs better than the baseline models. And the second point that you have to see is that the SAT-ACT-UT model performs better than the SAT-ACT model, which means that the hypothesis 1 holds. So to reiterate, if we add the utterance generation task to the satisfaction score prediction and the action prediction, we see the boosted performance. It actually holds on the action prediction as well. In the table 4, we see the results of the utterance generation, and you can also see that the SAT-ACT-UT model performs better than the simple utterance generation model, which means that the satisfaction prediction and action prediction actually helped the utterance generation. The last table is the cross-domain unweighted average recall for the satisfaction score prediction, and for the table, for the understanding, it means that the model is trained on, for example, on the multi-was data set and tested on the different SGD and CCP data set, and when compared to the BERT model that was presented by the USS data set paper, we can see that the SAT-ACT-UT model performs better than the baseline model here. So the conclusion is that we have presented the state-of-the-art performance in satisfaction prediction and action prediction, and as far as we know, it is the first work that combines the user utterance generation task with the satisfaction score and action prediction in a multi-text learning regime. And we verified the 2 hypotheses that the satisfaction score and action prediction and utterance generation task all gives positive transfer to each other when trained in a multi-task learning setting. Thank you for listening.
Thank you. Do we have any questions for Yun? Claudia, please.
Thank you for the talk. One question I have is, at some point you said the dialogue history is 10 utterances. So you always first look at 10 utterances and then you start predicting?
So it is up to 10 utterances. So it can be 5 utterances or 6 utterances.
So what is like the average number?
I would say most of them, because the dialogue history data set is very long, I think most of them are 10 utterances. But when generating the first few samples, it can be less than 10.
I think this has appeared on Slido, but I think it might be a question related to you. So someone's just written, how much data approximately is needed at a minimum to make the simulator work in a domain?
To be honest, I'm not sure about that, but if you look at our paper, as far as I remember, the USS data set, if you look at the USS data set statistics, there are a few thousand dialogue history data set there, and if we generate, if we transform the data set as we presented, we can create about 10K dialogue samples. Yeah.
Okay, thank you. Any other questions from the audience? Okay, we can leave it there. Okay, great. Thank you very much.
Thank you.
Thank you. Now, do we have the last speaker? We weren't sure if the last speaker was, the last speaker's here? Great. Okay, so we have Akshit Gupta from Delft University. Great. And his talk is To Trust or Not to Trust, how a conversational interface affects trust in a decision support system. So we can't see a screen just yet.
Can you hear me?
Yes.
Is the screen visible?
Yep. Oh, we got it now. Thank you.
Oh, good. Cool. Hi. So my name is Akshit, and I will be presenting a work originally published in the web conference regarding the effect of conversational interfaces in building trust for the context of decision support systems. Just starting with some background and some intro, and probably it will give some motivation as well. The title of the paper is a mouthful, so let me just break it down. Decision support systems support a person in making decisions, especially when there are complex variables or when there are a large number of variables that might prove too much for a human brain. And we are already aware about the proliferation of conversational interfaces like Alexa or Siri over the past years. Interestingly, in the field of crowdsourcing, conversational interfaces are also being deployed. So you see Amazon Mechanical Turk or Prolific. In the last 5 years, more and more conversational interface tasks are being deployed, and there have been some interesting studies in that as well. However, people actually tend to rely on automation and systems they trust, and tend to reject systems that they don't trust. Hence, it becomes imperative to find or explore how these interfaces affects the building of trust in these systems. Trust in literature is a multi-dimensional concept and has been defined in multiple ways, ranging from reliance of an agent to situational trust, depending on the context, and to learned trust based on past experiences and behavior of the human with the system. For the purposes of our work, we define trust as an attitude that an agent will help achieve a user's goal in a situation characterized by uncertainty and vulnerability. This definition is also pretty popular in literature, and it's actually defined by DNC. In other words, the user actually has no ability to control the agent. And this agent can be any computer technology or another human in itself. And all this leads to a research question, which is how a conversational interface and a traditional web-based interface compare with each other for building user trust in the context of decision support systems. To find answers to our research question, we actually designed 2 interfaces or tasks from scratch. These are micro tasks in pure technical terms. The first one was a web interface task, and the second one was a text-based conversation interface task, and organized a 2x2 between subject study on the crowdsourcing platform Prolific. The general task design for both conversational interfaces and web interfaces is as shown in the figure. The user or participant in the study was given a house hunting scenario in a situated experiment for a city in Netherlands. So actually, all of us come from TU Delft, and the city was actually Delft, and Delft has a lot of issues with finding the correct housing. So that's how the motivation for the scenario came up. Was actually we came up with. The user actually or the participant was also being constrained to Netherlands only, and he or she was asked to enter the housing preferences into the system based on the text presented in the scenario, and a house was recommended by the decision support system. The preferences entered by the user can be maximum rent, nearness to the supermarkets, or the type of house, whether it's a studio or sharing, and things like that. So in total, there were 6 preferences. And at the end of each task, we had a variable accuracy of the decision support system, as well as variable order of easy and hard scenarios. So just to give an example, this figure actually shows the conversational interface task. Here, C1 is actually the scenario text, which was given to the participant or the worker or the participant or the user on Prolific. C2 is the attention check question, and C3 is the place where open-ended conversation takes place. And C4 is the submission of house to the system, and C5 allows to move to the next stage of the task. Just to make it even more clear, if you read the scenario text, it gives you a name. It says you are Alice, you're looking for a place to stay in Delft for at least a year. You are an international student and require registration in the municipality, and so on. So based on this text, the user has to come up with the preferences that the person in this scenario has, and the attention check question in this case becomes the name, which is Alice. A similar task was designed for the web interface task, where the house hunting scenario is also shown in the figure. Sorry, actually, I'm not sure if the image is that clear, but it's actually the same text. Just the way the user has to fill is to a web-based interface. So here, W1 is the house hunting scenario, as well as the attention check question, and the user is allowed to submit preferences at W2 using drop-down boxes or check boxes. And the decision support system recommends a house in W4, and the user can still look at all the houses at W5 and then submit the best one. So this entire setup, the tasks that were shown before, were actually arranged in a 2x2 between subject study. The first 2 actually stands for the interface, which can be conversational interface or the chat interface. And the second 2 stands for the accuracy of the decision support system in the tasks. Each participant from Prolific was asked to complete 2 tasks, one after the another, in which the interface always remained the same. To measure the user's affinity with technology, an ATI questionnaire was used, and the trust of the user in the system was measured after each task using the popular rescue questionnaire on a 5-point Likert scale. And this figure is actually elaborating what I just said. So it's basically the flow of the task, flow of a single task on Prolific. Moving on to results, we saw that for both low accuracy and high accuracy decision support system, in case of a conversational interface, the trust and satisfaction scores were significantly higher than a web-based interface. Further, for the conversational interface, the accuracy had a significant effect on both trust and satisfaction scores, whereas the same was not true for web interfaces. This suggests that the user interface has significant effect on building trust in the system. And in our case, at least for the context of decision support systems, and maybe even making it more concrete for the domain of house hunting scenarios, the conversational interface had way higher trust than the web interface. A similar result was also seen from the user behavior analysis for each of the interfaces. We see that for the conversational interface, people in general were less inclined to look at all the houses and instead choose the house that was recommended by the decision support system compared to the web-based interface. And this also led to the lower completion time of the conversational interface compared to the web-based interface. So overall, we found a three-way trade-off between the user trust, the active completion time, and the user performance. The user performance here refers to the worker performance on cloud computing. So here are our main takeaways. We found that the users tended to both trust and be more satisfied with conversational interface than traditional web-based interface for the context of decision support systems. Further, a decreased accuracy of the system was more detrimental in case of conversational interfaces than web-based interfaces. And although we hope to generalize our results, it would be interesting to see the effects of different domains on these results, as well as adding a purely voice-based interface into the loop. So that's about it. Thank you for listening. And yeah, for any questions, feel free to mail me or shoot them later as well. Thank you.
Okay, thank you. Questions? Actually, I had one. In your conclusions at the end, you mentioned that the accuracy of the system was more important for the conversational interface than the web interface, if I remember correctly. That was your last point. Just remind me why that was the case.
Oh yeah, so in the results for the decision support system, which was configured with both high accuracy and low accuracy, we found that the difference or the delta for the trust scores for conversational interfaces was actually significantly higher. Like it was around, I think, 0.4 or something. Whereas for the web-based interface, it was pretty much equal.
Right. Sorry. Could the AV guys, could you just get the screen share back up again, please? But did you have an understanding as to why that was the case? It's just so you've just told us what the results were, but do you have a sense as to why that was happening?
We did try to postulate, but we did not verify why that was the case. But one of the reasons that we thought was, since the user was already trusting the conversational interfaces more than a web-based interface, they were actually less likely to question the recommendation given by the decision support system or the system in that case. Okay.
I mean, one thing that crosses my mind about trust in these systems is that a key sort of element in trusting a system is the ability to sort of recover from errors, and I wonder whether that has some sort of implication in these different interfaces.
Yeah, that's pretty interesting. So I refer that the repairing from errors in this case for conversational interface, you're mostly referring to the task flow or the chat flow in which the user is not able to understand something. And to basically rectify that, we always had a fallback intent. And for the web-based interface, it was a pretty straightforward task flow. So right now, in my mind, it doesn't an error. A point of error does not come specifically, but for the conversation interface, it's possible that there might be tasks, and then we analyze all the fallback intents as well, like and it was, I think, only 5% of the tasks of the chats that went to the fallback intent. So yeah, but yeah, it's interesting to actually further explore this as well.
Okay, do we have any other questions from the audience? Okay, so we'll leave it there. Thank you very much. Thank you for the talk. Thank you.
Thanks.
What Svetlana asked me to do now, although I'm going to be looking at her as well for inspiration, is for us now to just have a conversation about about questions related to evaluation of conversational systems. What we've had here are 4 talks, and if I could sort of sum up those 4 talks, the first one, I'm very struck. These are all papers. These are all presentations from papers that I think have appeared in other conferences, and we've seen conferences, CEI', 2 information retrieval conferences, ECIR and SIGIR, and then the last speaker was from the web conference. The first talk was sort of quite a pragmatic study of just the way of studying conversational systems using experience sampling. We then had a sort of an examination of these, you know, a conversational evaluation, if I remember, using the CAST system, and then multitask-based neural model, which was a sort of a user simulation approach, and then finally this kind of examination of 2 different types of interfaces. So it's very clear that evaluation is an extremely broad topic in conversational systems. I can see that all of our speakers have stayed on the line, and I guess maybe our physical speaker could perhaps join us as well. So let me start off by sort of asking our speakers, do you have a sense, yeah, why don't you, I guess, I don't know, you could, do you have a sense as to what needs to be done next in order to improve the evaluation of conversational search? Let me ask Jing.
I guess for me, because my work is actually not on conversational search, so I guess my suggestion would be on the more general view, how to evaluate, especially for me, because I'm doing ECIR research, how to evaluate user behaviors and try to understand why users use like certain phrases, why they may behave like that. I guess my suggestion, if you do want to evaluate conversational systems in the wild, you need to do it carefully and ethically, try to capture as more data as possible, because like if you interpret user behaviors by your logs or by the data, by the like search terms, that does not uncover the whole picture of the interaction. They might be cooking or they might be doing other things, but those are not revealed in the data, and maybe then the activities people are doing, the context in the environment might be impacting how they use certain phrases, or like where they are may also impact the user behavior when using conversational systems.
Thank you. I mean, I suppose the interesting challenge here is that we've got, your experiments with something like experience sampling, you know, what you're doing is you're trying to capture things of sort of people in sort of real situations, and then you're sort of prompting them to explain what's been going on. I mean, often these more complex systems require very large amounts of data. Sorry, just remind me, how many users or how many people were involved in your experiment?
13.
13 or 30?
13.
Yeah. Okay. So yes. Okay. So then, I mean, I guess Guglielmo. I mean, that then sort of, you know, those kinds of scales just aren't really. You need something much larger for sort of. Well, I don't know. Your evaluation approach used a sort of something different, right? You were working with CAST data, if I remember correctly.
CAST agent?
Yeah. So I agree with the fact that we certainly need more data. So it's probably the most obvious element, and we all agree on that. We are constantly working as a community toward collecting more data and particularly more diverse data, because I think we all agree that one of the biggest challenge with this specific domain is that it is really vast with really different declinations and different aspects that all are worthy of studied. So in this sense, we need more data and more diverse data, and actually more real data from one aspect. In my opinion, to go back to your question, so what we need to do next, I think that one important aspect is also to revisit what we have done up to now. I mean, currently, in general, in IR evaluation, the typical strategy is based on computing means and using statistical tests, which often involves the assumption that events are independent, and in this sense, they can be easily treated with our typical statistical test and traditional way of using them. In conversational search, or in general in the conversational setting, this is not true anymore. In fact, we have users that interact for a long time with the system for inducing multiple events, and which cannot be treated separately, and which cannot be assumed to be independent. So besides certainly considering the next step, new measures, new paradigms, which are certainly a key aspect for evaluating better systems, which we should also reconsider part of our tools and better understand how can we use what we already have in order to better understand how this system works, and how can be treated and compared when used in reality.
Just to thank you. Just to I could probably throw this to the other speakers as well. I mean, Ewan, I mean, where do you think we need to go next in terms of evaluation, or for extending evaluation?
So as I said in the presentation, so the current evaluation, I think, is kind of limited to the single path or the single turn of the evaluation. So I think to tackle that problem, we can use the user simulation and let the conversational system to chat with user simulation, and we can make a lot of different metrics, including the user satisfaction, within the user simulator, and then while making a conversation with the dialogue system and the user simulator, we can track the performance of the metrics that are shown in the simulator.
Okay. I mean, I guess the thing I'm really realizing, and I come to this as an outsider, you know, my experience is in test collection evaluation, but I'm realizing just how extensive the complexity is here. You know, so we've got in some ways very pragmatic questions about how well the speech recognition works, and you know, mischaracterizing 5 as bi. You know, then we're sort of talking about questions of satisfaction, but then also we also sort of have notions of trust as well. So I think it's a much more complex task, I guess, than a search task. Is that right? Or?
Yeah, I agree. Yeah.
And I mean, So are there other senses then? Akshit, you were sort of examining trust in the dialogue system. What are the other aspects that you think we should be examining in addition to trust?
So this work actually started based on some other literature studies that have been done in crowd computing. So some of the interesting studies, or some papers which I found really interesting, were on user engagement and keeping the user engaged basically in a crowd computing task. So So cloud computing is more of a field where usually people used to have traditional web-based interfaces, and engagement is one of these things that can actually really change the user goal, like basically the goal class of the user completely. So that's one thing that comes to my mind immediately, actually. Other things that can be looked into is the reliability, actually. So we were looking at trust, and we defined trust as a situation characterized by uncertainty and vulnerability. But what if that situation is not characterized by uncertainty? So just looking at the reliance of a system, and there are tons of, let's say, questionnaires designed for measuring reliability of web-based interfaces. But it would be interesting to see that in a similar kind of study as well.
Okay, so engagement, and then also just questions of reliability. You were saying. I guess actually I was just going to ask a sort of a slightly different question. So, Ewan, with your user simulator, I mean, to what extent is it possible to take sort of lessons from, say, Jing's experience sampling, which can sort of modify the way the simulator works? Or, you know, I'm just trying to think of ways in which one can, because I mean, presumably the user simulator that you had is driven from very large amounts of data. To what extent is it possible to adjust these simulators based on sort of small scale studies?
So we can, I think we can try the ASR error correction within the simulator, or we can incorporate the user's ASR errors within the simulator. In order to perfectly simulate what human does in the simulator, then we can simulate a bad pronunciation or something that causes the ASR error within the simulation. And I think that can be another challenge for the next future research.
Okay, yeah, that's kind of an intriguing idea. Look, let me just round out this conversation by asking each of you what you think is needed for further progress in evaluation. So, you know, it could be things like data sets, annotations, more user simulators, better metrics. Perhaps I could go to Guglielmo. What do you think is needed to progress evaluation and conversational search further?
Well, in my opinion, one thing that we probably need is somehow a better definition of protocols and evaluation strategies. As you were saying, there are many different tasks, each of which is treated differently. And even though there are already several works that try to simulate, or as in my case, to resample conversation, the point is that we mostly need data, and we need protocols to use such data. We need to clarify what are the objective of each of these systems, which can be very different depending on the task that we are planning to address. And for each of these, we need both protocols that allow us to be comparable with other strategies, and we need more data, either real data, annotated by real users and in real processes, data collection processes, or at least simulated data as a large part of the community, I think, is agreeing toward, since already, as I was saying, there are different works that try to simulate new conversations and generate conversations from what we already have.
Okay, thank you. Akshit, what do you think is needed to make further progress in evaluation?
I actually would add on to the answer that Guglielmo gave. So in the field, especially for trust, there is actually a lack of standardization, or it's just true even in case of fairness in ML, basically, or fairness in machine learning, which kind of relates to this. So most likely, or most possibly, if possible, to have a standardized set of protocols that can be used to evaluate these systems can be a really, let's say, important step in measuring the reproducibility of the results. So in our case, we used 240 workers, which was kind of a big number, but we have seen also studies where people have, I don't know, 10 users or even 5 users or even 50, but we don't know the variability of those users. So maybe a standardized set of protocols, even with, let's say, the evaluations set up and even the metrics that can be used it would be pretty great actually to have that.
Actually, just to build on something that you were asking earlier, I just noticed there was a question online, because earlier you said, that it was important to think about what aspects should be evaluated. Someone has commented, I guess that's also dependent on the task at hand, because conversational systems nowadays are used in a multitude of applications. So evaluation should be tailored appropriately as well, I suppose.
Yeah, it's pretty. I would agree with that comment, but having a tailored evaluation for a particular task, which we actually did for our task, it's probably maybe two types of evaluation can be done, where we have a broader evaluation and then a specific task-wise evaluation.
Okay, thank you.
So a particular instance that I can probably add on is, let's say for computer vision, there are some tasks which require precision highly and some tasks which require recall, but some require F1 score. So these are kind of standardized. So something like that for conversational interface.
But are there sort of known groups of conversations? Is it sort of well understood the different types of conversations that might be sort of had where one can sort of categorize those things?
So I'm not sure actually, because I'm not into the classification of conversations. But when I'm referring to task-independent evaluation, it's more related to domain of evaluation. So let's say healthcare domain versus robotics.
Okay, thanks. Jing, I know this is slightly sort of, you come at it from the CHI sort of perspective, but do you have a sense as to what's needed to make further progress in evaluation?
Yeah, just from where I'm from, I would recommend to have more SCAI researchers on this area, and let's do more in the wild study. That's what I find might be insightful, especially when you're talking about conversational search and you're considering there's only one person doing the conversational search, but in reality, there may be others, and others' behavior might be impacting how they speak to the system. So you really need to do it in the wild study and repeatedly to figure out, like, maybe there's something we unseen before.
Yep. Oh, okay. No, thank you. And finally, Yun, what do you think? Just give us your final thoughts on ways to make further progress in evaluation.
So I would like to say in terms of the user simulation perspective. So when evaluating the simulation, then it is very important to track the utterance generation as well. But I've taken some samples from the results that I've made. So for example, if the ground truth sentence was, thank you very much, but now I would like to search about the pasta place, then if the result was, I appreciate it, then that should be considered as a perfect generation, because the latter part of the ground truth sentence, which was the I want to go to the pasta place, it was completely newly brought up by the user. So it was really kind of impossible to generate the new sentence that was brought up by the user. So I think there must be some metrics that can track those users' new topic or personal knowledges within the utterance generation evaluation.
Okay, all right. No, look. So I think I'll probably draw the conversation to a close there. I just want to sort of thank all of you. I'm just sort of sitting here kind of stunned that I'm talking to someone in the Netherlands, in Italy, in Melbourne, for goodness sake, and 2 meters to the right of me, and just how seamless this actually works. But thank you all for your excellent presentations, just telling us about the work that you've published in these prestigious conferences, and thank you for staying online and just having this conversation. It's been really fascinating to me just to see the multiple, I'm sure this is not all of them, but the multiple aspects that are needed when considering all the different approaches that one can exploit when thinking about evaluation. So thank you all for joining us, and we'll bring the session to a close. Thank you.
Thank you.
Thank you.